I'm Dirk Ducharme, Editor-in-Chief with Quality Digest, and we're here at Indicate Technologies in Santa Clara, California, to look at an example of a growing trend in technology shows. You might call them open houses, we call them Micro Expos, and they're slowly taking the place of the larger trade shows that we're all familiar with, and which frankly are expensive for vendors and attendees. And also those trade shows have been seeing their audience diminish over the last decade or so. Now with me today is John Hammond, President of Indicate Technologies. John, tell me a little bit about how long you've been doing this Metrology Expo and the purpose behind it.
Well, we've been doing these types of what we've called open houses in the past since 2004. The early versions of it we called technology tours, but over time those have matured into what we're calling Metrology Expo. And for us, Metrology Expo is an opportunity for us to give back to the community while marketing ourselves as what we hope will be viewed as an important part of the industrial community.
How have these changed over the last few years? I mean, I've been to open houses. They're usually just kind of a, hey, come to our place, we're going to have some beer and pizza and you can look at our equipment, but this seems a lot more than that.
Well, we try to make it more of a working party for enthusiasts who are interested in dimensional measurement. So what we try to do is have some content so it can be a working party of sorts. We do still have the food and not the beer, unfortunately, maybe after we're done at the end of the day. But what we do try to do is have more of a party atmosphere, and oftentimes people in our industry are excited about technology, excited about new tools to implement what they're trying to accomplish. So we have all the latest technology, all the latest tools, people in from all over the country and around the world to transfer their expertise to our customer base through a series of technology presentations, as well as just being available in an unstructured, casual environment with the tools and the people who are interested in the tools.
Now, as a distributor, what's the value in this for you?
Well, there are a number of things, but we really want to use this expo as an opportunity to highlight our position in the industry. On a higher order, we want to be seen as a community player. We want to be part of this community in a way that's not just selling equipment to the industry, but more providing a value of transferring the tools to our customer base, providing information and expertise to our customer base so they can be successful implementing those tools.
And what's the value of this to the attendee? Why come here as opposed to a major trade show?
Well, part of it is cost. Part of it is that the attendees are actually able to meet the people who would support them locally.
Oh, okay, so the vendor that they're going to possibly buy from is also going to be a local distributor or local vendor, and
right.
The person they're going to be working with throughout the year if they buy that product.
Right. As we're here, we're a local distributor. We're available all the time as part of the Metrology Expo. We bring in representatives from the factory from around the country and around the world, so that we basically bringing this to the field rather than having the field come to the factory.
And not to mention it's a lot cheaper to come here.
Sure, and hopefully equal fun.
Well, why don't you show us some of your vendors you have here?
All right, let's walk around here.
See, we have a person from OGP over here. Hi, your name is?
Tom Groff.
Yep. Tom, what's the value of this type of small show, what we're calling a Micro Expo, for a vendor?
It's great to bring our equipment locally to customers. We find that you get much more personalized information. People can come in for demos and spend extended periods of time going through product demos and learning a lot about the equipment with both the presentations that he puts together and with all of the different equipment that we bring.
So a bit more hands-on than they might get at perhaps a larger show.
Exactly, and they're it's kind of an overload when you go to a trade show. You got a lot of things and you hit a little bit of everything. Here you get a little bit more time and a little bit more attention.
So yeah, so the vendor can be a little bit more personal with their existing clients or potential clients.
Exactly, and it also connects them to the local rep a little bit more and introduces them to all the people that support them locally.
Okay, thanks.
On this part of the show, we have Mr. Dan Mancini of Edmonds Gauges demonstrating some air and electronic tooling. Very precise air gauging. Dan gave a technical presentation yesterday morning regarding the general use and practices of air gauging.
Okay. And wow, what's this?
Well, this big box, refrigerator-looking box, is as an X-ray and CT scanning system by the Metris Group, now a part of Nikon Metrology.
Correct. And this is CT scanning, so just like medical CT, but
industrial.
Computer tomography, right?
Computer tomography.
Okay.
And another thing that we are, in answering some of your question earlier, Dirk, about why we do these shows. We do these shows every 2 years, and we use it as a means of setting the tone of business for the coming 2 years. One of the things that we're doing is trying to highlight the elements we're focusing on. One of those, in this case, is the expansion of our contract inspection services, which now includes the CT scanning.
Okay, so this equipment is here, and it's available not only for demo purposes and to show potential clients, but you also can do real inspection on it?
Correct.
Okay.
This particular system is by View Micro Metrology. It has a number of features that were highlighted at the show, primarily in the theme of high accuracy, high speed, non-contact measurement using vision and laser.
And this is 2D or 3D?
This is a 2D data acquisition and, 3D data acquisition and 2D analysis.
Okay.
Over here we have some analytical software that we use in our lab and that we attach to some of our laser scanning devices that it's called TrueMap, and it's by a company called True Gauge. And this enables us to do various different types of very fine analysis on small features on surfaces.
I notice you have a optical comparator over here, but this is a little different from what I'm used to seeing.
Yes, it is. Thanks for noticing. Approximately $3 million of research or development has gone into this technology. This comparator is by Optical Gauging Products. It is motorized, it has edge detection, and one of the exciting things is that it has what we call ECAD, which is using CAD models to generate an electronic overlay template that's projected onto the image of the comparator, as opposed to using a manually printed overlay template that's always been done in the past.
So instead of a Mylar, they're actually are somehow projecting this CAD model on top of an optical display.
We're projecting the nominal geometry with the tolerance zone onto the part. Over here we have two different pieces of equipment from RAM Optical. Here we have one called the Scan Fit Measure system that is based on a flatbed scanner. It's a single button push ability to acquire data and do the proper analysis relative to the ANSI or the ASME Y145 specification, which is the GD&T.
So this is just a really high-end flatbed scanner?
You could look at it that way. There have been many things done. The base technology is flatbed scanning. However, there have been many things done to improve the accuracy. Now, this can produce accuracy of 0.2 of a thousandth, which in our world is not very accurate, but for many things is perfectly adequate.
Sure.
Mr. David Lopez here is setting up this Starlight GX system. This is a very, very basic manual-driven video microscope that has some fairly capable automated software attached to it for edge detection and analysis. This is essentially the equivalent, the analytical equivalent of our high-end automated systems, but it's done with manual drives, so it's much more affordable. This system starts at $12,000.
Wow. Okay. So if they don't need the automation, they don't need the throughput. This would be your Bowie.
It's a big bang for a little buck, especially for a lot of the startup companies that just need to get to the next rung of the ladder.
Okay.
Here we have another system by Quality Vision International. It's called a Cobra. It's a laser scanning system with doing profile trace.
Okay.
This might be one device that we would take data into that TrueMap software and do further analysis.
And this is strictly for surface profile, is that?
Strictly for surface profile.
Okay. Yeah. What do we have back here?
Well, let's see. In this room, this is our rapid prototyping forum, and this is Scott Anderson here of Rapid Form, who's demonstrating the ability to acquire data on a part with this arm. This is actually an arm by Nikon Metrology as well. It's called a Model Maker Z. Okay. It has a laser and a touch probe built into it. It gives us, Scott, the ability to acquire data on the surface of this part, which is interesting, however, not what he's primarily focused on. What he's primarily focused on is what the software over here does, which is the XOR software. There are a number of different modules, but what Scott's been demonstrating here in these modeling workshops is the ability to take the acquired point cloud data there and develop a parametric solid CAD model in the matter of 30 minutes to an hour, a task that otherwise might have taken days or weeks. this is really cutting edge productivity here.
Well, first step is getting the scan data, and then we can make a CAD model from it, so you can use it with other engineering software, manufacturing, CAD, CAM. So rapid form is an enabler from the measurements to get into a physical form or a digital form that can be used for manufacturing, assembly, simulation, analysis. So we can generate those CAD models, or in particular native CAD models. The native CAD model is great because if you want to change the slot location or change your profile, you can do that with a native file format. So if you got a SolidWorks modeler, you get a SolidWorks file from the scan data, and then it's balls to the wall. You can start manufacturing and making parts that work.
Outstanding. So what do we have in this room?
Here we have, well, this is the ScienceScope room of microscopes, inspection scopes, and an X-ray system.
Now, is everything we've seen so far, is this all equipment that is normally here, or has some of this been brought in just specifically for the show?
Most of it is here, although some of it has been brought in. Mostly the tools that have been brought in are things that we've had hard time getting. The lead time is long. The factories are shipping to our customers, so we can't keep them here for demonstration units.
Okay, and ScienceScope does what?
ScienceScope does a pretty wide range of things. I think their general manager says they make small things look big.
Once you know that from a scope, right?
Yeah.
Okay.
They facilitate inspection.
Okay.
There is the CCP Comparator out here. There's quite a few things here that are interesting. Certified Comparator products has been the focus of and the creator of the most interesting and exciting technology for optical comparators developed in the last 100 years. Recently, they've spent over $3 million developing 4 new elements to these comparators. LED lighting, which has been used for a long time now in all kinds of imaging systems, but applied to an optical comparator. Video-based image capture built into an optical comparator. These things don't typically go together.
Okay.
As well as edge scanning. The ability to push a button and have the system scan and measure a circle or a slot. Probably the most exciting thing here for me is what we call ECAD, which is the ability to generate overlay templates, which everyone on optical comparators is familiar with, but now instead of generating them as a physical artifact, generating them from the CAD model and projecting those nominal geometries with their tolerances as an overlay on the CAD model that follows the model as we go. So it will update and show us how the image of the part fits into the allowed envelope.
So is this basically the same technology we were looking at on the OGP optical comparator over there?
It is the same technology, and there are many similarities in the way they've been implemented. However, there are subtle differences, and the OGP implementation tends to be a little bit on the higher scale, some more integration, and the CCP tends to have taken a slightly different approach with different types of automation.
And what would be the cost of a product like this?
These comparators range from $10,000 up to about $35,000.
So still relatively inexpensive.
I would say so.
And you're talking even with these features on them.
This comparator here with these features would list price out at about $30,000.
Oh, okay.
Yeah.
See something bright orange back here.
Our orange room. These are the Laserlink guys. And Laserlink is primarily involved with the online control for extrusion, wire, and cable.
Okay.
This is an excellent picture that tells of their world. This is the cross-section of a piece of tubing that is actually being dragged through 2 sensors here. One is a laser micrometer, a triple beam laser micrometer tracking the outside dimension of this tubing. This one is an ultrasonic sensor using 4 different transducers capturing the wall thickness of that. By combining the outside dimension with the instantaneous wall thickness, we're able to determine the ID as well.
So this is a model or a demo
Yes.
of as if you were measuring an extruded part like this, right?
Correct.
Is that what's happening? Okay.
This would typically live right on the extruder and often be used to feedback and control the extruder.
To control the wall thickness in real time.
Yes, by either changing the puller or changing the airflow. So it can be used strictly to monitor and document, or it can be used to actually close the loop and control. One additional exciting development that is unique to Laserlink is the ability to do this
but not just with plastic tubing that's been done forever, but to do it on a very challenging material, in this case, nitinol, which is a memory metal, and it is, I think its most common use is still under wires for bras, believe it or not, but that's not what they're measuring here. This is the tubing that's typically used to be cut out and used for stents for implants in the human body. Also in this room we have other Laserlink devices. These are not for use online, but these are used for use offline. And this particular one has a rotary axis built into it. We can use this very nice self-centering chuck to load a part, press a button, have it automatically rotate and pick up different features around the outside diameter. Now another one of Laserlink's characteristics is their ability, they have a very nice a la carte approach. They have the ability to interface with anybody's laser micrometers. Their first objective was their software to control the extrusion process and to take data from different sensors. From that, they've developed their own array of sensors, as you see here, and have been quite successful. But it's a nice approach because this is a mature industry with many sensors out there being used, and with this tool, we can come into a facility and improve what they have with a minimal investment in a software using their existing tools, and as that matures and as they need more, we can continue to replace those tools with maybe some more capable tools.
There's quite a variety of equipment that you have here in 4,500 square feet. So what do we have over here, John? Looks pretty futuristic.
This is a non-contact measurement tool, Dirk, and it's designed to do non-contact surface metrology using microscope objectives and a technology that's not well known in industry. It's called focus variation.
What does that mean?
Well, what that means is it's going to scan the optics in the z-axis, collecting data the whole way, and trying to determine determining the focal point of each data point in the field of view by looking at contrast change.
So basically, you're focusing on different levels all the way through a Z range.
Yes.
Okay.
This particular one, in some ways it's similar to what we saw with the OGP SmartScope systems that does an autofocus using contrast. The difference is with the OGP systems, we're doing the autofocus and acquiring a single data point using a very large number of pixels. Here, we're accumulating millions of data points through the field of view. So every one of those data points potentially has a different z-axis location. So the result of one scan in the z-axis is a topographical map similar to what you see over here on the screen.
Okay.
Now this is the year date of a dime, and it's been scanned with this, let's see, we used a 10x lens.
So John, thanks for showing us around your Metrology Expo. You've crammed a lot of equipment and expertise into 4,500 square feet.
That we have.
So you're going to do this again in what, 2012?
2012, Metrology Expo 2012.
Okay, well, we'll be back here.
Looking forward to it, Doug.
Okay, thanks
for
man.
being here.
Okay.